Hello everybody, my name is Arthur. This is a demonstration of a piece of code that I'm writing for my uh, one of my final courses, which is a Python writing course. I decided to do it in Blender just because there's a lot you can do in Blender, and as you can read the project descriptions up here, it's basically to take an input of three functions that describe x, y, and z, all which respect, well, x, y, and z, and these functions use math to draw a line that represents a wire, and then I'm going to use Biot-Savart law to essentially visualize what the magnetic field produced by that wire would actually look like. So let me give a demonstration of this. I only have the first half of this project done, which is being able to draw the wire, which is okay. This is really just stuff that I've been kind of whipping up when I got the time, right? But let's run it, and I'll give you an actual look of what this looks like, and look at that. Ain't that pretty? So it creates a nice little spiral, a nice little coil, and what I hope to use this for is essentially to model antennas, I guess, if you could call them that. They wouldn't really be antennas because they're not, well, I guess you could say they're like near-field antennas. But basically I want to work with lower frequencies and be able to visualize what magnetic fields would be produced with different shapes of wire to see which ones would be the most viable for communication, for example, underground, or honestly, that's very much the only one I can think of right now. Point being, it's not super broad application, but I think it would be very fun at the very least. And you know what? The reason we do things in science isn't because we think they're useful, but because we think they're fun, and that's a principle you should live by. Well, maybe not if you don't want to get a job, but you know. But yeah, no, so it's honestly not rocket science. It's relatively simple code. These three just define x, y, and z. As you can see, x is a cosine, y is a sine, and z is just a linear function. So z moves linearly upwards, x and y oscillate and create a circle. We have a function that defines all the points, which is how it draws it. And we just have a bunch of functions that, so for example, vector sum here adds vectors, vector scale scales vectors, vector dot takes the dot product between two vectors, vector cross takes the cross product, magnitude takes the magnitude. It's really self-explanatory. And pretty much how this works is it just takes all those coordinates that are collected with this point function, and it just adds a cylinder at every single one of those points, or actually at the midpoint of each of those points, and it just adds a cylinder in each of those positions with a rotation function as well. And as I said, it's really not the most complex code out there. I just like math, and it's more than I do coding, so you know, this is just something I thought would be very fun to work on. Okay, still works. I thought it broke for some reason. But you can make ellipses, you can make a whole matter of things. You know, let's do that actually. Let's make let's say z is 0. You can't tell I'm having fun with this. So 0.5 times p times math.sine p, 0.05 times. I've also recorded this like 3 times, but I keep accidentally deleting it. You know, it's a Friday night. Sometimes, some days you just don't want to think. There we go. Look at that. Isn't that very cool? Oh, I love it. Love it, love it, love it. Yeah, this is pretty much what I hope to make for my project, and yeah, no, it's really quite simple, but honestly, I hope it looks cool. I hope the teacher likes it, and I hope all goes well. You know. Could change that too. Maybe that'll make it bigger. Anyways, I thought I did that. I was pretty proud of it, and I thought I would give a demonstration of it. So there you go. That's the project I've been working on. Thank you.